Hello everyone. Section 3.5 is a new part. Rate of change for functions that can be multiplied. So last section we talked about the function conversion. This section we are gonna talk about the function multiplication. So let's see. First, if we are given two functions, g of x and h of x, and we multiply them together, then we will get. So pay attention to the function notation. So this one is the function multiplication, this part. F of x equals to g of x multiplied by h of x. So actually here, g dot, this is a dot. A dot means a multiplication. This one is just the g of x multiplied by h of x. And the last section we are talking about the function composition. That is, for example, g of f of x. So here we have a whole, a circle. So not a product, not a dot. Instead of a dot, we have a circle here. This one, the first one means the function multiplication. And the second one means the function composition. This one equals to g of f of x. So the second one, you can see we have the inside function, and the output of the inside function is actually the input of the outside function. So the second one is the function composition. They are different right here and here. So for this one, for this section we only focus on the first part. So let's see, what is the product? Oh, what's wrong with it? What is the product of the, what is the derivative of the product of two functions? So this is the question for this section, and for the next question, 3.5 and 3.6. These two sections are talking about the derivative for the functions that can be multiplied. But for the section 3.3 and the section 3.4, these two sections are talking about the derivative of the composite functions. So you can see the difference. One is only for the composite functions, and the other one is for the function multiplication. So they are different. And then, so the question is, what is the derivative of this one? F of x, or what is the derivative of the product of two functions, g of x times h of x? What is the derivative of this one? So different from the, so you can see here, for this function f of x, x is the input, output is just the f of x. And for the second function, for the outside function g, f of x is the input, g of f of x is the output. So you can see the input and output for the two functions g and f are different. But let's see, the input, not just or we can only focus on the input of the two functions, f of x and the g of f of x. So you can see the difference. The input variables are different for the two functions, the inside function f and the outside function g. Then what about the function multiplication? For the function multiplication, the two functions, one is g of x, the other one is h of x. You can see here, both of them, the input variable are just x. So that means actually for the two functions, the input variables are the same. So that's another difference between the function multiplication and the function composition. For the function composition, the output of the inside function is the input of the outside function of the second function. But for this one, for the function multiplication, g and h, they share the same input variable. So that's why we can just use 1x for both of them for g multiplied by h of x. So pay attention to the input variable. Both of them should be the same, should be x. And then, so the question, let's try to answer the question, what is the derivative of the product of two functions? Then just for this is the very important formula. If this is your first time see this formula, just memorize this one. This is very important. So let's see. Okay, so we know f of x equals to g of x multiplied by h of x. Then let's see. All right, the derivative is a summation of two terms, the first term and the second term. So you can see both of them has, for the two terms, both of them we have g of x, h of x, g of x, h of x. But the difference is like one of them is g prime of x, the other one is the h prime of x. So it's like in order to make the two terms balanced, like they are the same important. We cannot say one is more important than the other one. So actually we have to make them similar to each other. So for example, the first one, we know we have only two terms. If you take the derivative of the first function, then you have to multiply by the second function without taking the derivative, just the function itself. So g prime of x multiplied by h of x plus, and then the other one, we keep the same g of x, then multiply by the derivative of the other function. So you can see, I hope this one will help you to memorize this one. Memorize this formula. It's a summation of two terms. Each term has one derivative, one original function, then multiply them together. So actually for this one, it does not matter which one comes first. So that means you can also rewrite it as g of x multiplied by h prime of x plus g prime of x plus multiplied by h of x. So they're the same thing because a plus b equals to b plus a. And then this one, just the derivative of the first function multiplied by the second function plus first function multiplied by the derivative of the second function, or you can just switch the order of the two functions. So next, let's do example 1 together. Then you pause the video and try to do example 2 by yourself. So first, still you can see the two functions, one is g of x, the other one is h of x. Both of them are functions of x. Then let's see what is the derivative of their product. Question A, 1a, the product function is this one, g of x multiplied by h of x, and this is the notation for the product of two functions. Parentheses g dot h, parentheses x means the g of x times h of x. So this one, then we are given g of x is right here, so just 5x to the 6th power, and then h of x is right here, natural log of x, ln of x. Okay, so this is the new function by taking the product of the two functions. And the next one, we use the formula. The formula is given, but now you have to memorize this one. But for this example, since this is the first time we use this function, we use this formula, so this formula is given directly. Then let's see, what is the g, so let's just follow it one by one. G prime of x, what is g of x? This is g of x, and this is h of x. So g prime of x is just 5 multiplied by 6x to the 5th power. So it is just 30x to the 5th power. This is g prime of x multiplied by h of x. H of x right here is given. So just multiply by natural log of x. And then the next term, g of x. This is g of x, 5x to the 6th power. Then multiply by h prime of x, which is the derivative of this term. That is just 1 over x. So next step, let's combine the common terms. So the first one is just the 30x to the 5th power multiplied by natural log of x. The first term is the same, and the second term x can be cancelled, so just 5x to the 5th power. Then we are done. So you can see next one. Note the functions and their derivatives are organized in a table. So actually you can see here it's like the derivative of the first function right here multiplied by the second function. The second function is there. So first we take the product of this term, then plus the first function right here multiplied by the second derivative of the second function, this one. So you can draw this one to help you. This is the starting point, and then the diagonal, multiply them together, then plus the off diagonal, and plus them, put them together, take the summation. There are many different ways to memorize this formula, but just no matter which way you use, as long as you can memorize it, then you're okay. So next, okay, so for example 2, please pause the video and do it by yourself. So for this one, if you haven't finished it, just pause the video and finish it first. Then now, okay, let's look at this question, these functions. Still, we are given two functions, g of x and h of x. So the first one, 2a, what is the product of the two functions? G of x is just 2 multiplied by 3 to the x power. H of x is just 3x squared minus 2x plus 1. Then we just follow the formula. G prime of x, this is our g of x, and this is our h of x. So the derivative of the g of x, g prime, oh yeah, so first we take the derivative of the g prime of x. This, remember, c multiplied by f of x, the derivative is just a c multiplied by f of x, f prime of x. Here 2 is the c, so we just keep the 2, and then multiply by 3, multiply by the derivative of 3 to the x power. It is just a 3 to the x power multiplied by natural log of 3. This is g prime of x. Then next term, multiply by h of x, just copy it, 3x squared minus 2x plus 1. Then plus g of x, which is 2 multiplied by 3 to the x power, just copy it. And then next term, h prime of x, so we take the derivative of this this one. So it is just 6x minus 2. So the last step, we multiply them together to see, let's see if we have any common terms. Oh, actually no. So we just rewrite it. Or you can just leave it there. Leave this one. Plus 1. Then plus 2 times 3 to the x power times 6x minus 2. So we can see here in the table, the first function, g of x, and the first function, g of x, equals to 2, 3 to the x power. The second function is h of x. That is just 3x squared minus 2x plus 1. Derivative of the first function, g prime of x, 2 multiplied by 3 to the x power multiplied by natural log of 3. Derivative of the second function, h prime of x, equals to 6x minus 2. Then we just multiply this one together, multiply this one, and then plus the other off diagonal. Then we have this one. the derivative. All right, next, example 3. Example 3, we are given 3 paragraphs. So first, finish this one in about A, B, C in about 7 minutes. All right, now let's take a look at this question. Example 3. Example 3, the first one, still, you can see here we are given 2 functions, s of x and t of x. The 2 functions, input variables are, both of them are x. So let's see, what is the s of x? What is the first function? S of x, the unit is many students. S of x, this one gives the number of full-time students, blah, 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 blah. So we know S of x, the unit is many students, and gives the number of full-time students. So we know the input is x. Then next, let's try to see what is the x. X is the number of years since the fall semester, 1999. So we know what we know the first function. Then let's see what about the second function. Second function, t of x, then we know the input variable must be the same as the first function, s of x. Then let's check it, where x is the number of years since the fall semester. Oh, yeah, they're the same. See, because both of them are x. The next, let's see, what about the t of x? What about the output unit? Oh, by the way, first one, this is the input unit. And so t of x, the output unit. Oh, excuse me, s of x, this is the output unit for s of x. Next, this is $1,000 per student. This is the output unit for t of x. This one gives the average tuition. So we know s of x is the number of students. T of x is the average tuition paid by student. So we know, after you read the question, you know, all right, we have 10,000 students here, and each student has to pay like about $10,000, $20,000 per year on average. So what is the total tuition for all the Clemson students? So we just multiply these 2 functions together. And then let's see the corresponding function graph. The first one, s of x. So here you can see the same. Oh, I'm sorry. This is not mailing, just mailing. You have to can include the whole unit. That is mailing students, not just mailing. This is a very common mistake. You have to use mailing students, not just mailing. So here, from the function graph, we can see s of x, mailing students. Input is x years since 1999. And similarly, t of x, the unit is $1,000 per student. And the input unit is the same, year, x year. And the next one, example A, question A. Now we take the product out of the 2 functions. So we have a new function based on the 2 functions. So, and we name it e of x. So e of x is a new function generated by the 2 given functions. So next one, try to answer the question, what is the input unit for the new function e of x? So we know for the function, for this one, it's a product of 2 functions. We know s of x must has 2 parts. The first one is the number, for example 10, and the second part is the corresponding unit. It's just the mailing students. So this is the full part of s of x. Next one, t of x. Suppose we have another, suppose it is 1,000 or 9,000. Then multiply by the unit. Number is the first part. Units are the second part. The second part of the unit is just right here, $1,000 per student. $1,000 per, you can just use the division per student. So this first question, for the new function e of x, what is the input unit? The input, what is the input variable? Just the x. So the unit for x is just a year. So the input unit is just the years. Then what is the output unit? So for the function multiplication, if we multiply these two terms together, first one we multiply the numbers together, that is 90,000. And then second one, for the units, we can do the same thing for the numbers. That means we can do the same multiplication. Then let's see, what about the function multiplication for units? So the common terms, students. So you can see here, we have many students. In the denominator, just a student. So actually, you can cancel the student. But you cannot cancel the mailing, because the mailing students is like mailing multiplied by students. They are separated. So you can separate them as a product. So you can see, we can only cancel the student. We cannot cancel the mailing. Then what about the left terms? Mailing multiplied by $1,000. So mailing multiplied by 1,000 is just a billion. And we have a dollars. So the output unit is just $1 billion. This is the input units, output units for the new function e of x. All right, next one is the question B. Question B, use the graphs. So we know we have to use the numbers in the straight function graph to find the total amount spent on tuition. So we know the question is, we use the three graphs to find the total amount spent on tuition by students. So we know we have to use the new function e of x. So, and what is the input variable? The input variable, the keyword is right here, in the fall semester of 2009. So go back to our x, it's x years after the fall semester 1990. So we know 2009 just means 10 years after 1999. So we know the input variable is just 10 instead of 2009. So what is the value of e of 10? So e of 10 is equals to s of 10 by using this formula. Is s of 10 multiplied by t of 10, because both of them, they share the same input variable. So both of them, the input are just 10s. And then next question, what about this one equals to, what is the s of 10? So s of x, we have to use the first function graph. When x equals to 10, you can see here, it's just 8.3, and the unit is million students. So we know s of 10 is just 8.3 million students. The next one, t of 10, similarly, t of 10 is just 4, and the unit is $1,000 per student. Multiplied by 4, $1,000. $1,000 per $1,000 per student. So here, still two parts. First, we use 8.3 multiplied by 4. Then we got 33.2. And for the unit multiplication, we can do the same thing. Student can be cancelled. Then it's just $1 billion, or you can just use this one. That is just $1 billion. Then you can just check what we have done. 33.2 is the total amount spent on tuition by students, and we have the unit $1 billion. Then that makes sense. The unit for tuition is $1 billion. That makes sense. So this is the second way to double check. This is a way to double check that your unit is correct. Next one is the tricky one. What is the derivative? So use the graph to determine how quickly is the keyword for derivative. So to determine how quickly the blah 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 blah. So we know it is for the new function g e prime of x, and we are given the same number. In the fall semester of 2009, that means 10 years after the fall semester 1999. So still, we have the same input variable, input value that is just 10. So we have the formula. Remember, in the beginning of this section, we just learned the formula for a function, new function f of x equals to g of x multiplied by h of x. The derivative is just we take the derivative of the first function multiplied by the second function plus derivative of the second function multiplied by the first function, or you can switch the order. So then let's go back to this one. So we use the same trick. This one equals to so because we know e of x equals to this one, so e prime of x just equals to s prime of x multiplied by t of x plus s of x multiplied by t prime of x. So now we are given the value of x just 10. So plug in x equals to 10. Then we got x prime of 10 multiplied by t of 10 plus s of 10 multiplied by t prime of 10. Then what is the s prime of 10? S prime of 10, we have to use the first model, the first function graph. When x equals to 10, we know the derivative also means the slope of the tangent line. At this point, we are given the slope of this line is just a 0.1. So we know the derivative when x equals to 10, the derivative is just a 0.1. And the unit is output unit per input unit. So just so the output unit, $1 million students, input unit per year. So it is just you can see here, just a million students per year. So this is our S prime of 10. Then this is a 0.1. Unit is million students per year. Million students, because they are separate, they are different units. So you can just think it as a product of two units, like million multiplied by students. Then it is easier for you to understand. Million students divided by per year means divided by year. They're the same thing. The next one, we are done with this term. Next term, t of 10. T of 10 is just right here. This is t of 10. So multiply by, just copy it. That is just a 4. Unit is $1,000 per student. Then plus S of 10. S of 10 is right here. This is S of 10. This is S of 10. So this is we can just copy it. That is 8.3 and the unit million student. Then million students multiplied by 10 right here. T prime of 10. T prime of 10, we have to use the this one. T prime of 10, still we use the same idea, just use this term. 0.2,000 students per year. We don't have enough space, so let's move it to the next line. This one multiplied by $0.2,000 students. $1,000 per student per year. So it's like student per year divided by year. So the number here is just a 2.06. So next, let's see how can we get the correct unit. So for this one, it's a summation of two terms. This is our first term. This is our first term. So this is this one and this one, the product of this one. This is our second term. It's like one apple plus. So we know the unit of the second term must be also apple. And so actually you can just check the first term, because we know if it is a summation of two terms, then the unit for the two terms must be the same, so that we can take the summation. So that means you can choose the first one to calculate for the unit, or you can just calculate for the second one. So in this one, I'm gonna do the both. So to make you understand, like, okay, actually they're the same. You can just do one of them. So the first one is many students the common term students cancelled. So the only thing left is just the denominator mainly multiplied by mainly $1,000. So the denominator just $1 billion per. In the denominator we have year, so it's just $1 billion per year. And then let's check the second term. The second part, mailing students. Mailing students, you can see here, it's better to make them one line instead of two lines. So student here can be cancelled. You can see here, student can be cancelled. And then we have mailing left, $1,000 left, so $1 billion. And in the denominator, we have year. So still, it is also $1 billion per year. They're the same units. Next one, next example, example 4. Example 4 is a very good example, very good exercise. So I'm gonna leave it as a homework questions. So this homework, I'm gonna post the PDF version of the homework online. So and for the homework, I will post the solution. So you can see Wednesday and Friday. By Friday, we are gonna finish the chapter 3, and next Monday is the review section. So for the review section, I'm gonna post the videos of the solutions. And for the solutions, pay attention. It's different from the It's different from the homeworks before the spring break. So for this homework, as long as you turn it in, you will get full points. So I will make sure you send me an email, or just it's better to send me an email by the deadline. The deadline will be next Monday. So you can see the details on Canvas. Make sure you emailed me the homework by Monday. And this homework, as long as you finish it, you turn it in. You can just send me a picture or scan it, or the easiest way will just be send me the pictures. If you finish it, you're gonna get full points. All right. So this is the first homework. This is the first question of the homework. And the next one, example 5. All right, pause the video and finish example 5 and example 7. Example 6 will be the second homework, will be the second question of the homework. So finish example 5 and example 7. All right, then let's see example 5. Example 5, f of x gives the percent of post-secondary students with some form of financial. So we know f of x is the percent of something. And the x is, when x equals to 1, when x is 1, means fall 2000. X is 2 means fall 2001. So you can see here, x means the number of years after 1999. So the second function, s of x, is the unit is mainly students. Then we know this one talks about something about the number of students. And then this one gives the full-time enrollment in American public schools, public colleges and universities. And they have the same x. This one, you can see they're the same. So the first one, write a model of the number of full-time students. Full-time students with some of financial aid, some form of financial aid. So we know this one is the function multiplication, and only the function multiplication makes sense. And then we generate a new function. Let's say this is a g of x. G of x equals to, but it's not enough to just multiply these two functions, because the first one, f of x, the unit is just the percent. So that means we have to divide it by 100. The first function, f of x, divided by 100, multiplied by the second function, s of x. So what is the f of x? This one, 3.09 x plus 54.18 divided by 100. Then times the second function. Second function is right here. 0.76 natural log of x ln of x plus 6.5. So, but we are not done because we don't know the unit. Then next, let's try to check what is the unit. The first one is just the percent. The unit is percent. So we use the second. We know the product of the two functions. The derivative of the product of the two functions is just made in students. Made in students. This one gives what? Gives the number of the right here. Gives the number of full-time students with some form of financial aid. And then we're not done because we talked about what is g of x. Next, we have to talk about what is x. Where x is just the number of years. So x is the same x. The number of years since the fall of 1999. And the next one is the calculator part, B and C. So make sure for B you get this one and for C you get this one. So let's see, what about the B? B shows you the function multiplication. You can see here, it's not a function combination. This is a function multiplication. In the last section 3.3, you can see we have a calculator instructions for the function conversion. So this one we only use the function multiplication. So function multiplication, y1 multiplied by y2. So you can see here, I'm not going to show you in the calculator. So this is the only way I can show you how to do it, just to repeat. So here you can see the first part. The first function is y1, and the second function is y2. And now we generate a third function, that is our y3. What about y3? y3 equals to y1 multiplied by y2. And so the question, what is the y1 of y1? What is the new function is g of x. What is g of 10? G of 11. So you can just, our g is just the new function y3. So y3 of 11. Then this one, g of 11, is just we use the 3 decimal places, 7.338. Unit is just made in students per year. Excuse me, it's not made in students per year, just the made in students. It's just the... And the next one, what about the next question? How quickly? How quickly just means the derivative. What is the same thing? What is g prime of 11? So for this one, you can see here. Now we in the calculator, our y3 is just a g of x. So next question, what is the g prime of 11? That means what is a y3 prime of 11 in the calculator? So for the derivative, we use minus 8. After you have the minus 8, we just plug in. You can see here the order. This one shows you the two different forms of the calculator. So your calculator, probably your calculator is one of them. So if you are the first one, make sure the first one is y3, then x. Then the last term is about the number. It's about the function value, the input of function value, 11. And if your calculator is about the second form, so we use dy3 dx, and the value for x is just 11. So no matter which one your calculator is, they must be the same answer. So the number is just 0.318, And the unit is output unit per input unit. Output unit is just million students. Input unit is years. So million students per year. Million students per year. Next one, example 6. Example 6 is the second question of the homework, in the homework. Next one, let's try to finish example 7. Use 3 minutes to finish example 7. Alright, time's up. So let's see, what about the first one? F of 4. We are given the function, new function, f of x. That is the product of two functions, g of x multiplied by h of x. The first question, what about f of minus 1? So then just plug in x equals to minus 1. Then we have g of minus 1 times h of minus 1. Then what is g of minus 1? This table, the first one means g of x equals to 5 when we are given x equals to minus 1. So that means g of minus 1 equals to 5. This is what this part tells us. So g of minus 1 just equals to 5. And what about h of minus 1? We have to use h of x when x equals to minus 1. So h of minus 1 is just minus 8. So we have minus 40. And the next question, what about f prime of x? F prime of x, we are not given the value of x, so we don't know the specific value. But instead, we have the formula by using this one. G prime of x multiplied by h of x plus g of x multiplied by h prime of x. This is our f prime of x. So the next one, we are given c. You can see the difference between b and c. B is the general formula, and c is, for c, we are given the specific value of x. That is just minus 1. So plug in x equals to minus 1. Then we have first one, g prime of minus 1. So we use this term. That is just the 0.02. And the second term, h of minus 1. All right. Let's plug in x equals to minus 1 first. So the first term, we know this is the first term. And the second term, h of minus 1, is right here, minus 8. Plus g of minus 1. G of minus 1 is this one, 5. Multiplied by h prime of minus 1. That is right here. So this is a minus 0.025. And the result is just 0.285. Alright, that's all for this section. Thanks.